Hello and welcome to Partially Redacted, a podcast where we discuss privacy and security engineering related topics. I'm your host, Sean Faulkner, and today I'm joined by Brad Micklea, CEO and founder of Jozu, and we'll be talking about balancing innovation and responsibility in AI and ML deployments. Brad, welcome to the show.
Thank you very much for having me.
Yeah, thanks so much for being here. It's always great to have a fellow Canadian on the show. But let's start with some basics. Who are you? What do you do?
Yeah, so I'm the founder and CEO of Jozu, as you said. And Jozu is a company focused on building AIML tooling, but for DevOps and application developers, not so much for data scientists, although obviously we love data scientists to use our products too. Our first release is actually an open source project called KitOps. And I'll be talking a little bit about that and how we help with the packaging of AIML projects. Before this, I was the general manager of Amazon's API Gateway, which is one of the most widely used services there. And that was an exciting gig, having such a big global responsibility. Previous to that, my last startup, CodeEnvy, which was a web IDE, the first web IDE that used containers under the hood as the developer environments. We were acquired by Red Hat in 2017, and I took over as VP of developer tooling, developer marketing, and developer evangelism for Red Hat. So most of my career has actually been largely focused on developer tools and DevOps tools, but I've spent some time more with tooling on the kind of IT side as well.
Awesome. I've been, I'm sure like many people, anybody who's done engineering on AWS is probably familiar with AWS Gateway and has used it. So that must have been a really fun project to be part of, just because of essentially the amount. I can't even imagine the amount of volume of traffic that's going through there, and it kind of puts you in a like upper echelon of like scale problems, I'm sure.
Absolutely. And you know what? It was an incredible opportunity for me. I mean, to run a service like that, which is global and across the world is doing literally trillions of requests a second. It's just mind boggling. Like you kind of have to reset everything in your brain to a different place. But it really taught me the importance of operations, of security, of that kind of diligence in how you approach your work. And that's something that we've tried to bring to KitOps, and I want to see happen a little bit more in AIML, which feels a little Wild West right now, for being honest.
Yeah. So is that where you saw sort of like a gap in opportunities, given that you spend most of your career sort of dev tools, DevOps, and then now everything's so sort of brand new and shiny in the world of like AI, generative AI, all the AIs basically. And, a lot of that work historically has come out of sort of like academics, and maybe the tooling's not sort of where other like software, more mature sort of software engineering type of tooling would be. Is that sort of like the opportunity that you're interested in sort of building for?
That is, and it came kind of tangentially out of my experiences at Red Hat and AWS. In both cases, I was lucky to have small kind of data science kind of groups working for me. And starting in 2017 at Red Hat, like that was still fairly unusual. And it was a great exposure, really, really wonderful. But it reminded me, both my parents are scientists, and my dad was the head of research and development for Nabisco Brands, makers of like Oreos and Ritz crackers and stuff like that. And so growing up, he would come back with these like just plain cardboard boxes of test cereals, because he ran the test kitchen too, or cookies or whatever have you. And we would do A/B tests and have to mark down which ones we liked the best or liked the least. And so I kind of got used to that. But it's interesting to look at a data science from that perspective. It reminds me of my father, who, when he would find a new cookie or a new cracker, as far as he's concerned, that's it. That's the one that's working. That's done. But of course, it's not done. That's really like the start. And then it has to be marketed. It has to be named. It has to be priced. It has to be distributed. All these other things that go into kind of turning it into something that you can actually buy and hold and eat. And it's kind of the same with the AIML. You've got the data scientist. And when the data scientist is done, it's not really done. That's really just the start. And there's a lot of tooling to help the data scientist get to that point. Training models, experimenting with models, fine-tuning models, all that stuff. Tons of tools for that. And they often call themselves MLOps, but it's not really the ops side of it. It's the dev side of it. And we really saw this actually in working with models for doing kind of business and finance analysis. You worked with data scientists who really only had to run the models on their laptops. And that was good enough. It was fine. It was using internal data. It was for answering internal questions. It was great. But then, yeah, as you start thinking about what it takes to take something as well known as, a standard microservice and run that at scale in something like AWS, how is that going to look for something as relatively unknown as an AI model? Like, it's mind-bogglingly different.
Yeah, absolutely. I mean, so first of all, the fact that your father used to bring home cereal to do A/B testing, like that sounds like a child's dream to
It
be
was
part of
pretty cool.
the test kitchen process. So that's awesome. But so I had spent some time in my career as a researcher when I was doing sort of more academic work, and in a lot of my work was like similar to this experience that you're talking about, like data scientists have. Essentially, you're focused on solving a problem. You do some sort of analysis through tooling, machine learning modeling or something like that to sort of get to the answer. And then it's kind of like that's done. It's like, now I have my answer and you kind of move on from there. But things change a lot when suddenly it's not just about getting the answer, but actually building like production enterprise grade systems and applications that are using and leveraging those models at scale. And you're right. Like there's just not tooling available for a lot of that stuff, at least probably not outside of some of the major companies that have done this at scale, but not for that sort of average technology company. And there's a lot of unknown challenges with actually being able to pull that off.
I think you're absolutely right. That's exactly it. It's interesting because I was the opportunity to chat with a customer about a big kind of retail provider who has global operations, and their data science team had built this fantastic model that could very correctly estimate how many pieces of clothing in different sizes would be needed for each geography. Super valuable, because obviously you don't want any waste there. Great. So the data scientist hands it off to the app teams. The app teams integrate it with the systems they have in production. That takes a bunch of time, required a bunch of changes. It eventually gets deployed, and it's working great. Now, from the app team's perspective, they were really just helping to deploy a model that they never built, they didn't own, they don't even really fully understand. So from their perspective, that's not their responsibility. But like you said, for a researcher, for a scientist, their job was done when the model was proven to work correctly for what it was meant to solve. And so they also aren't sitting there staring at what is it doing in production. Over the course of the following 3 years, that model drifted, because that happened. And eventually it was giving bad recommendations for what these sizes should be. And that's a business impactful problem. And part of the issue was just the handoff was not clear. The ownership wasn't clear. People weren't sure where to find like a new version of the model, the old version of the model. Where would they get the data set to retrain it? All these questions. And there just wasn't a structure around how to deal with that. That's the stuff that we're really trying to target.
So as we start to sort of like transition into this world where machine learning models are really going beyond just the use by a data scientist and actually beginning to be used by application teams and to build actual like core product that are going to be consumer facing. Like, what are some of the gaps in terms of the tooling that is required? Like, presumably changes the bar in terms of the tooling that we need. Like, you probably need like observability and reproducibility tools, testing, all these types of things, automation. But like, what are some of those gaps that are not there now?
Yeah, that's a great question, Sean. So like I said, I think, when you look at what is called MLOps tooling today, what you're really seeing is rich tooling around the development models. So that part, everything kind of up through the development is good. On the operation side, though, it is really lacking. I think for a lot of people, the thought is, well, a model is still code. And I deploy code by putting it inside of a container. I run it through a pipeline. It's in production. We're good to go. So as long as I can containerize it, it's good. And yes, you can do that. But a lot of models, the way that they're built, their parameters for how they're run are kind of built into the model. And if you containerize that whole thing, for example, well, then anytime somebody needs to change those parameters, you got to rebuild the whole container. You got to redeploy the whole container. That's a little risky, a little ugly. One of the things I learned at AWS is it's obvious, but you really learn to feel the pain of it. There sometimes is any change to production is bad. You should do as little as possible. And so things like that don't work that well. You need the observability, like you mentioned. One of the things that I think we need to be worrying about in a way that is different with AIML, more so really than I'll call them more deterministic services that we typically use, is what is the provenance of those things? If I find out that my model, let's say I have a set of models out in production, and I find out that one of my data sets has included sensitive data that it shouldn't have, I know some of the models, 1, 2, 3, I don't know, have been trained with that data set. How do I know which? Am I going to go and ask every data scientist? I mean, it's not a very efficient way to do it, and they're probably not going to remember. So there's questions about that. There's questions about how do you deal with that drift? How do you replace the model? How do you tweak the model? There's a lot of things that I think, that we know already we need to deal with. And I think with the point you were making, which is absolutely correct, a ton of stuff we don't even know that we're going to need in the future. And I'm not even touching on the, kind of governance and security side, which we know is evolving really rapidly.
Yeah, I think that's like a natural thing that happens. Like if you look at the transition from sort of pre-internet era software development to internet era, or then to mobile as well, like new tool chains that basically were created with each of those change in terms of like form factor of the way that like consumers are going to interact with applications, because the same thing that we were doing for, maybe testing or deployments for desktop web applications didn't yes, maybe they sort of worked a little bit, but like they weren't perfect for mobile. So then you had to develop like new things, new analytics tools and all those types of stuff. And I think that transition is probably even bigger when we start to talk about things like large language models, because one, it's something that I think a lot of people don't have that much domain expertise about. Even the experts don't even fully understand like what exactly is going on. And then you also talked about the fact that like we could be training a model with, sensitive data, and then we don't know where it is. And even if we do know where it is, like, how do we get it out? And that's already a problem even outside of AI. I think I read the other day that 40% of enterprise customers don't really know where their customer data is, like fully. So, and that's just in like databases and stuff like that. So if you don't know where it is, you don't know, what you're storing, it's pretty hard to secure it. You can't be compliant. Like it just becomes a completely intractable problem. And then you're adding on top of that a system where you can't even delete the information, even if you know where it is.
That's right. It's funny because I think what this reminds me of, I don't know if you've ever seen the TV show The Bear.
Yeah.
But you've got these in a kitchen, you've got chefs cooking stuff. You've got, and there's different chefs cooking different parts of the dinner plate, essentially. They've got to be super coordinated. They got to know what each other is doing. You've got people yelling about what new orders are coming in. You've got waiters coming and taking things out. There are so many little handoffs. And I think in software, sometimes we forget that it's those little handoffs that will either result in a kitchen that runs smoothly, patrons are happy, everything's running, or things are not running smoothly and it's really ugly and your users are walking away. And I think that's a kind of underappreciated aspect of this problem, because it's exacerbated, like you said, by the fact that if I don't understand what a large language model is, let alone what this particular one does and how it does it and where it does it, I can't infer things. I can't just assume, oh, well, that's probably going to change in this way, or that's probably going to, be updated at this time. I have no idea.
Mm-hmm. So what do you think is the biggest sort of current gap in the tooling? Like where is the biggest pain that companies are feeling when it comes to like deployment of models?
So I think that one of the biggest problems is the one that we've focused on. That's why we focused on it. And it's shockingly common and it sounds really simple, but I think there's a lot of nuance here and a lot of reason why it's critical. And that is a packaging mechanism that allows you to do handoffs cleanly. An AIML project is not like a microservice. Your model code is going to be, let's say, in your Git repository, but your data is probably massive. It's not there. It's somewhere else. And it's separately versioned. It's probably owned actually by a different team. You've got configuration parameters that you need to keep track of. And then you've got the serialized model itself. So you've got all these pieces and they're all in different places. In some cases, they're owned by different teams. And when it was just data scientists working on those, it was kind of okay. They could kind of muddle through. But now you've got to get an app integration happening. So there's an application team that now needs to know, well, which of those data sets do I go grab to validate this? Which model do I grab that I'm integrating with? You've got an site reliability engineer, a DevOps engineer who needs to actually deploy this thing. And today there is no package to do that. Instead, you have your model maybe in a container and all these other different things. And so you're juggling all these different assets. Not only is that logistically hard, but as we were talking about, the what is the provenance? How are these things connected? I can't with any confidence know that the model that is containerized perhaps correctly and beautifully, what data set it used when it was trained. I have to go talk to somebody and hope that they remember. So we've really focused on building a packaging model we call model kits. That package includes all the code, whether it's training code or model code, whatever have you, the serialized model itself, the various data sets that you might require at different stages, your training data set, your validation data set, maybe integration testing data sets, all the configuration, all the code, everything else. We package that into the model kit. That model kit is immutable. And so it has a SHA digest associated with it, along with SHA digest for all the individual components. And then that can be stored in your registry. Now, as you're developing as a data scientist, you're just creating these model kits at kind of each stage. Okay, I finished training, here's a model kit. I finished experimenting, there's the model kit. I finished integrating with my app, model kit. So now I can say, regardless of where I get it, no matter who I am, no matter when I'm using it, that is absolutely the same model with its data sets, with its config, as is in production or as is in development. It doesn't matter, wherever it is. So it feels like, something that should be easy, but it's actually something that's quite hard. And we've wanted to make it easy, which is why we focus.
So why is it like that, existing tooling, like existing tools that exist in like DevOps space aren't like applicable to this particular problem?
Yeah. So I think that parts of them are and parts of them aren't. So, certainly if, like I said, if you're going to package your model in a container, then you can put it through your normal pipelines that you use for any other container, and that would work. There are aspects though that are different. Like typically, AI models will shift over time. So they need to be monitored for that drift. And you need to have kind of a feedback loop from production into your deployment pipeline, which isn't something that most deployment pipelines have by nature. You've got the observability issues. Like I said, you've even just got these packaging issues and this idea that, you don't want to be caught in a situation where sensitive data was used to train and I don't know which model was impacted. So I'm going to have to either pull them all out, which is probably what I'm going to have to do. And that stinks, rather than be able to go, oh no, it's just that one model. Let's grab that one model. Or it was the model before the one we just updated. So in fact, none of the models in production were impacted. Phew, aren't we lucky? So it's these kind of problems that the existing tools just don't have a mechanism to solve. They don't have that chain of kind of trust. You don't have that package. There's no way to do that today. So they've kind of got a data set over here and a code base over there and a container over here. So.
Right. Okay. And then as I'm building these model kits, then what is sort of the typical workflow? Am I pushing those into something like GitHub so that I can manage the different versions and pull down different models when I need them?
Yeah. So the model kit itself is essentially always versioned as you create it. So you're naming it in the same way that you would, kind of tag a container. And you would place them into a registry. So that could be Docker Hub, it could be GitHub's container registry, it could be Amazon's ECR, wherever you want. And in fact, Jozu is going to be releasing in the next couple of months a hub that is purposely designed for these model kits. Because when you put a model kit in a normal, container registry, you can't do cool things like see what's inside of it and understand what the attestations are and follow that chain of trust, or grab only the model and not the data sets. But these are the things that Jozu Hub will allow you to do, which gives you a lot more modularity, a lot more freedom. Because, of course, as you're developing, you may need all those different artifacts. As you're integrating, you maybe just need the model and a data set. And as you're deploying, you maybe just need the model. So you don't want to have people having to pull down whole model kits, which can be massive, if all they need is one part or the other.
Mm-hmm. And then how does this approach address some of the privacy security challenges that companies face when it comes to model deployment?
Yeah. So With this audience, especially, Sean, I think I want to be really clear that this is it's not really a security product. However, I would call it a trust product. Because like I said, we are able to say, and you can validate that this model kit package has not been tampered with. And so I know that this model, if it has the same digest as the one over there, is the same model. It was not changed. It was not played with. Same thing with the data sets. And that I've always felt is kind of that's the foundation you need to build security on. If you don't have that confidence and that trust, if you don't know that that data set, even though it has the same name, is different than the one that you were expecting, that gets you into a lot of trouble. So there's companies out there that focus strictly on the kind of, prompt injection or other types of security issues. That's not so much us. We're more wanting to make sure that customers can kind of achieve more of a compliance type, confidence with those assets.
Ideally, I think, there's going to be like dedicated tools, like you're talking about, like something that's like, works on, preventing prompt injections or, monitoring those types of things. But ideally, whatever product that you're using as part of like your development tool chain is like secure by default. It's like, it shouldn't, basically the seatbelt shouldn't be an additional purchase on top of the car. Like they should just come with the car. Same with the brakes, right? Like you shouldn't have to pay for those things. They should be basically built in rather than bolted on. So it sounds like you've been trying to take that approach of like, hey, like we need this thing, but here's some of the value that it delivers also from a like security perspective, because you can actually trace what data was used as part of the model training process. So you don't kind of just like lose track of what data was used and where it is.
That's exactly it, Sean. And that's actually why this is an open source project, because ultimately what would make me happiest, and certainly where I think we need to go, obviously, is that these model kits should be used by every vendor as the de facto way to package an AIML project, because it would just make it safer. It would give us greater confidence. I'm sure you heard recently that there were hundreds of models found on Hugging Face that had malicious code in them. You should be able to know, hey, this model came from that person and used these data sets, and be able to look at that chain and say, I'm okay with that chain. I'm comfortable with it. Or, I don't know, I'm not sure about that. I don't think I want to go down that road. And so packaging, again, is a way that you can kind of bake all that stuff in so that people don't need to think extra about it. They don't need to go and jump through extra hoops. It's just, is the package untampered with? Do I trust who built it? Then we're good. And if I don't, I can make a different choice, a safer one.
Yeah, absolutely. It makes a lot of sense. I mean, it's kind of like doing like pulling a publicly available package, like a Java package or something like that. There's, I can go and pull that randomly off of some repo I find on GitHub, or I could go to like an actual registry where there's a little bit more guarantees in terms of like trust and stuff like that, to where I can feel a little bit more confident that it hasn't been tampered with or it's not doing something malicious. And when you start to think about like these kind of like supply chain attacks that can happen in the LLM world, it gets a little scary, because it's easy to hide stuff, and the kind of natural interface with LLMs, especially if it's sort of like a copilot or chatbot, is just you like naturally want to share fairly sensitive stuff with it, and they're going to see everything. So if that's dumping the data somewhere unbeknownst to you, then it's not a good place to be, I guess.
That's right. And I think this is going to be a set of problems that we're just going to continue to see. Like if you imagine it would be tempting, and again, not faulting anyone, but it might be even natural for somebody taking a scientist's mind to a problem to say, okay, well, if we want to build the best possible AI to answer customers, product problems, support queries, let's train it on all the data we have from every customer that's ever come through support. But there could be a lot of sensitive data in there. And it sounds smart. It sounds like it makes sense, but it would absolutely open it up for somebody coming from the outside to ask certain questions of that support bot and suddenly start learning things about customers that they absolutely shouldn't. And, you could do that. There's so many different ways that can happen. protecting yourself by at least understanding what have you done yourself? What have you controlled yourself? What have you pulled from outside? And do you trust that source? Is at least a good start. But it's certainly not the whole answer.
Yeah, I mean, I think there's a bunch of things that you have to kind of put in place to do this like holistically. But we did an episode recently on prompt injection attacks. And one of the things that we talked about on that episode was that we keep pushing a lot of responsibility onto the LLM for protecting itself when it wasn't really designed to do that. Like it's designed to essentially like, produce written content if it's a, large language model or something like that, or produce an image. And then you're trying to essentially like tune it to stop it from doing certain things through like these guardrail mechanisms. But it's a lot easier to essentially move some of that responsibility outside of the world of the LLM, where we understand those technologies better and we have more sort of control over it. Like you're talking about with these like packages is like, okay, I know that this was the data that went into training that model, but if I'm trying to only guardrail that, and understand that at the LLM level, like I'm just losing a lot of visibility and control over what's actually happening.
That's right. I think it's somewhat like a kind of mental context switch. One of the things that was fascinating going to AWS was just the huge and correctly relentless focus on security that they had. And it was a kind of mental switch that needed to be flipped of realizing that you get habituated to how do we help the customer? How do we help the customer? How do we help the customer? And that's right. You should absolutely do that. But there are times when the correct answer is we can't help the customer because it would compromise security in some way. And, to your point, it's not necessarily the way LLMs have been trained. They have not been trained to have that kind of built-in guardrail. But I think at some point that's going to have to change. I think there's going to have to be more specialization of LLMs if we want them to get to a stage where they are more naturally protected, or we're going to have to build walls upon doors, upon locks. And I think there's going to be some combination, but I kind of feel like you got to do a little bit of you got to train something to have the outcome you want to start with. Then you guardrail around.
Mm-hmm. Yeah. I think it's a very difficult problem because these are like open systems. Like if you think about like designing the UI where the interaction is going to be a series of clicks, and basically the product and engineering team is going to think through like, what are all the things that someone needs to accomplish? Like, how do we make sure that they're successful with that? And you have a lot of control over where that person's going to go. It's like you're basically building like a Disneyland ride for them where they're going to be steered down a particular path. But when the only interface is a text field and I can write whatever I want, and it's like, how do you control essentially the behavior of what someone puts in? So it's so open-ended that it's hard to think through every essentially scenario that someone could put in that exploits a limitation in the system or the guardrails that you put in.
Yeah, in fact, I think it's impossible. To be honest, it's one of the reasons why I don't really like the kind of chatbot style, UX, mm-hmm. And I don't really see how it can. It certainly doesn't seem like it's going to be state of the art forever. It feels like you need something. I honestly, even as a user, sometimes I think you want something a little bit more directed anyway than just tell me something, so.
Yeah, I mean, it kind of is like we used to talk when I had a couple of years ago about what we called the free beer problem, or you go to some specialty store in San Francisco that sells beers, and you look at the wall and there's like thousands of beers on the wall, and you're like a deer in headlights. It's like sometimes the absence of choice is somewhat freeing when you don't want to have to be like bombarded with the decision-making process of the choice. And if the only user interface is a chat field, then I have unlimited choice all the time, and I have to think through like, what is it that I actually want to do? And that might not always be appropriate for the interaction that you want to guide your users to.
Yeah, exactly. Yeah, that whole free for all kind of sense, I think, just is really kind of stem to stern in the AI world right now. I think that's again why some of these things are so difficult operationally to manage and to understand, because, like you said, you've got such different types of people in such different types of roles, data scientists and app engineers and SREs. And it's difficult to coordinate I mean, we've all been there. It's difficult to coordinate across multiple teams, even when the technology is well understood, the problem is well understood, the solution is well understood. It's still not easy. And in these cases, in general, like you said, the technology isn't as well understood. The solution may not be 100% precisely understood. So we need more, I think, at least for now, we need more tooling to really help us get there. And that's actually ultimately where I really want to see us take Jozu, is the model kits are, I think have one life path where hopefully they're adopted broadly and just can become a standard, a safety standard, convenience standard for AI projects. But for Jozu, I feel like where the world is going is we need to have a platform where these very different teams can interact with each other, can kind of understand when they need to step in and get engaged and when they don't need to, because everyone's busy. They can't stay on top of every project, and it's not helpful to have project managers yelling at you 24/7 about every single project that's going on. And so having that kind of on demand, like, hey, this model is finished, all of its training, but it hasn't been validated yet. This might be a good time to do a smoke test with your application integration to see, did anything change? Are you going to need to make some app changes because the model changed? Now it's finished all the validation, it's finished all the testing. Okay, now SRE, now it's time to start the packaging. And now think about, how do we build this into our observability platform for production? I don't see that those conversations, those triggers are not happening right now. And I think that's in some cases why I read a Gartner statistic, which was terrifying. So we were like, I think only less than, or maybe it's just over 50% of AIML projects ever make it to production, which is shocking. Like, that's just, can you imagine if that was our life with microservices? Like, everything would grind to a halt. But I think it's these handoffs and just the communication, and how do I communicate with somebody when I don't know their language? Like, it's challenging.
Yeah. So this model packaging,
the model
kit, approach, that's sort of the first step towards this. So how does that, like, currently, like with that using that project, if I adopted that, how does that sort of change the way the different teams might be doing model deployment from not having something like that today? Like, how does that, impact the DevOps team or the application engineer?
Yeah, great question. So I think, we talked a little bit before about the fact that one of the things that I think companies need to be worried about, and having worked with some of these things, in production, I can kind of be a bit of an oracle, I guess. One of the things that people are going to hit, I think, is that the data scientists don't really know what it means to operationalize something. And so it's not necessarily going to be clear to them how to highlight the importance of different types of changes, whether it's in the data sets or the codes of the model, wherever. So you've got these application integration teams that are going to be grabbing things, hoping that the right kind of things. You got people packaging things and hoping it's the right thing that they're pushing out to deployment, to production. And hope is not a good strategy. So adopting a model kit, the data scientist works, let's say in their Jupyter notebook, they finish their work and they post it as a model kit. Now, if that gets posted, the app team sees that and says, maybe they label that particular model kit that it's going to be the next model kit or the challenger, champions out there in production. So now the app teams goes, okay, we've got a new one. It's marked challenger. And then for me, that means I need to get engaged. Now they just grab what they need from the model kit. They know, again, they can verify that it's the right thing, that it's untampered with. They do their work. Now their app is ready. Now the model is ready. Now that gets handed off to an SRE. Now they flip let's say the label from, challenger to deployable. Now it's deployable. SRE goes, okay, great. We got a deployable model. That's for me. Now, the model kit project is going to be able to spit out a container with your model in it, if that's what you want to do, or it's going to spit out a special kind of container that knows where the model is and can kind of connect into your production system, and do that, again, knowing that model that it's connecting to is the right one, hasn't been tampered with, all that good stuff. And so that then just smoothly gets deployed via those same production deployment solutions that already exist, have already been proven to work, that are secure, that are compliant. And that's important because what I see some companies doing, and it's understandable, there are these MLOps tools that are designed more for the development side, but they want to be able to deploy. So they have a deploy button. And that basically just pushes the thing out into production. But talk to any, SRE, talk to anyone who's done infrastructure, management and production. You don't want things just getting rammed into production. Like there's a set of tests that need to be run. There's checks that need to be checked off. It's not as simple as that. It's not just about can you get it there. It's how do you get it there? And so one of the things that was really important for us as building these model kits is make sure that the tools that people had spent so much time building out, that these pipelines that just work, that you should be able to leverage those. And so now you've got a situation where everybody can be coordinated through the model kit. They can have confidence and clarity about what's there, but they can use the tools they want. The data scientist is using their data science tools. The app engineer is using their IDE and their debugger. The DevOps person is using their pipelines. And that to me is how you get to a fast, efficient, safe, confident workflow.
And in terms of the models that I can use, is this assuming that I'm essentially packaging the model within the kit, and then that's going to run within a container? So this is like an open source model, or maybe something I built internally within my own company?
It can really be anything. So we've used it with relatively kind of quote unquote simple, machine learning models. We've used it with large scale LLMs. But the assumption is that, yes, it's something that I am tuning myself, I'm building myself, I'm developing myself, and that I'm going to be kind of deploying or hosting myself. Yeah. So obviously, if all I'm doing is integrating with, let's say, OpenAI's APIs, model kit isn't really necessary. This is more for that situation where I need to grab Llama 2 or, Mistral, and I want to be able to do some special fine tuning for my specific work and then run that.
Mm-hmm. Yeah, makes sense. And then how does some of this help with testing and reproducibility as I'm evolving the model?
Yeah. So reproducibility, I think, to me is night and day, because like I said, otherwise you got to know I'm grabbing this thing from there and that thing from there. And you really are relying on things like, is the naming what I expect the name to be? I don't really know if it changed or if it didn't. It's most of your team outside of the AIML group probably doesn't have an inference server running their laptop. They probably don't really know which data set intuitively to just use to test their integration. So you need those kind of things. And the kit CLI, which comes with the model kit, that actually allows you not only package up and unpack these model kits, but it has a dev mode that allows you to, it'll just set up a little inference server on your machine, allows you to just run an LLM or run the model and kind of see what's going on there if you just want to play with it or you're trying to integrate with it or test it. So I think from a reproducibility perspective, again, you always know that the model kit with the same kind of digest, the same code is the same no matter what. So that reproducibility helps already. And then you can package it as a Docker container. You can package it as an init container. You can package it for local. You can run it wherever you want.
Do you think that there's a difference between MLOps and LLM ops, or is that just, people sort of trying to run the, jump on the LLM gravy train and throw that in as another type of ops?
I'll be honest, I don't see a ton of difference. Let me put it differently. I don't think there's enough difference to justify calling them two different kinds of tools in most cases. And really, if you look deeply at most of these tools, most of the ones that are specialized in LLMs started off doing just machine learning, because until a couple of years ago, nobody really was working with LLMs. So no, I don't think that there's a big difference. There are some, there's some cases, edge cases, I think, where you've got something that works fundamentally differently, but by and large, I think it's largely similar.
Mm-hmm. Yeah, and in comparison to something like what you're doing in a company like Weights and Biases, Weights and Biases really starts more with the sort of data science tool chain and then kind of ends there. And I think they're probably trying to maybe, move beyond that now, but it's that gap really of, like you talked about earlier, that what happens after the data scientist is done with the model.
Yeah, I mean, the way I think about it is that you've got 1,000 tools designed by data scientists for data scientists. You've got almost no tool designed for app devs and SREs, but that are focused on AIML problems, which is a slightly different problem set than a microservice or than a mobile application. It looks different. It behaves differently, and it needs something different.
So now that you have this, first project, it's open source, people can try it out, even presumably contribute to it. Like, what's sort of next for Jozu? What are you focused on next?
Yeah, so the next big thing for Jozu is that releasing of that kind of public hub so that people can start sharing these model kits, grabbing the model kits. We're going to offer that publicly, of course, so people can do this as a community, but also privately, because it is going to be important for companies to be able to say, no, these are my model kits. I'm training them with my data. I don't want other people's hands on them. And in fact, a little later on, Jozu Hub will be available to install in your own environment. So you can really be sure that the privacy is there. Beyond that, like I said, I think that the thing that is most important going forward is finding ways to really help these teams collaborate, and the data science teams with the app and SRE teams. And I think there's a lot of tooling that still needs to be built to help with that. I see a lot of kind of workflow-based tooling and communications, a lot of different things that we're going to be building out to help, not just with deployment, and some of these more immediate issues, but with some of the bigger, broader issues of things are going to continue to go wrong in unexpected ways. It's those unknown unknowns, unless you have people who can interact with each other, who can know when to hand off, how to do that safely.
And then as we start to wrap up, is there anything else you'd want to add or share?
I guess just that I've always believed that the best products are built in collaboration with a user community. And so for those who are listening, if you found this interesting, if you find it intriguing, really encourage you to go to kitops, KITOPS.ml, and check out the project, try it. We would love to get feedback. It's, I've always said it's the greatest gift you can give someone, your time and your thought. And I would love to hear also about what things people think we should be focused on, because there are so many issues in right now in connecting those different areas. Love to hear back.
Awesome. Well, we'll include that link in the show notes. And Brad, thanks so much for being here. I really enjoyed this conversation. I think I agree. Like, I think there's a huge opportunity here. Like we talked about, like with these transitions that happen, you just need a whole new tool chain, and someone has to build that stuff in order for these things to really move beyond demos and prototypes and proof of concepts that are running on someone's laptop to be able to run this at scale to serve millions or billions of people.
Awesome. Thank you so much, Sean. This was a pleasure. It was a good conversation. I really enjoyed it.
Thanks, and cheers.